Today we're going to look at the integral mean value theorem and what that means. So your objective is to be able to find the average rate of change or mean value and then apply the average rate of change to the real world. Okay, let's start with our mean value theorem of integrals and then the function we're actually going to use to find the answer to these problems. Okay, so the mean value theorem states that if f is continuous on the closed interval from a to b, then there exists a number c in the closed interval, such that the integral from a to b of f of x dx equals f of c times b minus a. Okay, that's the theorem. If you don't understand what the theorem is saying, that's really okay because we're going to apply it to the average value of a function here, okay? And this formula below is what we really need to know. Okay, so this is just a way of applying the mean value theorem to integrals. If I want to define what f of c was, I could divide both sides by b minus a, and I would end up getting this integral here. Okay? Whether you see that or not, that's really what is going on here. So it's just another way of rewriting solving for f of c. And that's what we're going to use when we do these examples below. Okay, so the average value of a function says if f is integrable on the closed interval from a to b, then the average value of f, i.e. f of c, on the interval is 1 over b minus a times the integral from a to b of f of x dx. Okay, so we're going to use that to find in these examples the average value of the functions on the interval given to us. All right, so the first one here is f of x equals 3x squared minus 2x. Okay, this negative 2 to 2 cut off, and that should be here. Sorry about that, that cut off the page, so please fix that. And then what I would do is just split your paper in 3, so we'll do the 3 problems. Okay, so let's look. We have f of x on an integral from a to b. So when we do the formula here, b is going to be 4 and a is going to be 1. Then we'll take the integral from 1 to 4 of f of x, the function, okay, to find its average value. So this will be 1 over b minus a times the integral from a to b of f of x dx. And let's just substitute everything in. So b is 4. I'll have 1 over 4 minus a is 1 times the integral from 1 to 4 of f of x dx is just that entire function. 3x squared minus 2x dx. Okay, so this is the average value, or f of c. Okay, so let's integrate that, or simplify. So we got to do the fraction and the integral, okay? So this would be 1 over 4 minus 1 is 1/3 times, now integrating 3x squared would give me, let's do a big parentheses because we're going to integrate this, would give me x to the 3rd. And then integrating 2x would give me x squared, but this is negative, so minus x squared from 1 to 4. Okay, double check and take the derivative quickly. 3x squared, that checks. Negative 2x, that checks. Okay, so now thinking of your fundamental theorem of calculus, you'll have to plug in the 4 minus the 1, and then we'll just times everything by 1/3 at the end. So 1/3 times, now let's plug in the 4 and the 1. So I'll do 4 to the 3rd minus 4 squared minus, sorry, I have a bunch of brackets going on, but 1 to the 3rd minus 1 squared. Okay, hold on, I wrote this wrong. 4 squared, not 4 times 2. Sorry. Okay, so we have 4 to the 3rd minus 4 squared minus 1 to the 3rd minus 1 squared. All right, so this will be 1/3 times 4 to the 3rd minus 4 squared. 4 times 4 times 4. Is 64 minus 16. Okay, so that gives me 48 minus, and then 1 to the 3rd minus 1 squared, that's 1 minus 1 minus 0. So this is 1/3 times 48, which is 16. Therefore, f of c is 16. That's its average value on that interval. Okay, that's how you do number 1. All right, let's do the next one. F of x equals sine x from 0 to pi. All right, so if you go through the formula, 1 over b minus a times the integral from a to b, f of x dx, that will give you the average value. Okay, so a in this case is 0, b is pi. Let's plug everything in and go from there. So this will be 1 over pi minus 0 times the integral from 0 to pi of sine x dx, which equals 1 over pi times the integral of sine x is negative cosine x. So make sure you times by the whole thing, because we're gonna have to plug in the pi and the 0, and then we'll multiply it by 1 over pi. Okay, and take the derivative to check yourself, and you'll get the same thing. So this would be 1 over pi times negative cosine pi minus negative cosine 0. All right, cosine pi is -1, and cosine 0 is 1. So with all my signs here, I'll have negative -1 minus -1, which is a positive 1 plus 1, 2. Okay, and we gotta times that by 1 over pi. Two over pi. That's the answer there.